tells me that the audio is connected. All right. So what are we going to do tonight? Are you going to verbalize problems, or do you want to send me a copy of some of your review material?
If you'd like, I could do either.
I think it would be better if you sent me a copy.
Okay, I'd need a minute.
Do you have my email address? Because send it to my email address. Let me write it. You might have it before. In fact, if you type the first two letters in, it'll probably show you the default. I don't know if you ever sent me anything before, but that's where I would like you to send it.
Okay.
As opposed to you send it to my phone, I can't bring it up on my computer screen easily. But if you send it to my email address, I can.
Okay. One thing I know, I mean, I'm going to need like 5 minutes for it to get up because my iPad's dead at the moment.
Okay.
But it's plugged in. I know what we're going over, piecewise functions.
Okay.
Stuff like, making...
You want to verbalize a piecewise function? Go ahead and we'll do it. What are you on now? You must not be on your iPad. You on a computer?
I'm on my computer, yeah.
Okay, but your material is on your iPad.
Yeah,
okay.
It is. Yeah, so.
Now, I need a problem. Now, if you like, I can go to my algebra book and pull up some piecewise functions while your iPad is charging. It's always better if you bring the problems to the table because here's the problem. I can bring up piecewise functions, but I'm not sure if the degree of difficulty on my problems in my book are the same as they are with what you've been doing. So it's really better if you bring the problems rather than me.
One second. I'll hopefully, just try one out. I might be able to do it.
Okay. Hold on.
And then hopefully by then my iPad will be working so I can send it to you.
Let me open my book to piecewise functions and let's see if I can get one. Now, you undoubtedly have to do two things. You have to take a piecewise function and graph it, and then you have to take a graph and come up with the piecewise function, right?
Yeah, pretty much. Mostly graphing it. I don't...
Okay, let me draw.
I have to see my material.
I've got one here. It says f of x equals, it's 2x minus 1 when x is less than or equal to 1, and it is 3x plus 1 when x is greater than 1. Okay?
Okay.
Now, let me help you think about piecewise functions. The way to start is to always start here.
Yeah.
X is less than or equal to 1 if I draw a dotted line through minus 1, then the area that I'm going to draw this is that area right there.
Okay.
And the function I'm going to put in is 2x minus 1. In other words, in that area that I shaded red, my function is 2x minus 1. Couple ways to do this. Let's do it the way that's most understandable, but I don't really like, and then I'll go back and show you the way I really like to do it. If I were to graph this function, 2x minus 1, it would go through the y-axis at minus 1 and it would have a slope of 2, correct?
Yeah.
So it would look something like that. With me? Well, the problem is that it's only this function to the left of minus... Is that minus 1 or plus 1? Hold on, let me back up. Helps if I don't make a mistake.
Can I get your email one more time?
Yeah, let me write it.
David, I think I might have it.
David Cowan, 1949.
At what?
Email.com.
Okay.
If you don't have it, you will now. For the next time.
So David Cowan 1949 at gmail.com?
Yep.
Okay. I just sent the material that we went over for my test tomorrow.
Okay.
So you could get a more accurate vision.
It's better to always do that. Let me check my email and see if it came in yet. Yep. All right.
This is how far I got today in class before class was dismissed. So the answers, the ones with the answers already there, I mean, you can check them to make sure they're right at the least, I mean, I guess.
Okay, let's talk about them rather than go through them so much.
Okay.
Of 2, which domain is that? Is it the top one, the middle one, or the bottom one?
The middle one.
That's the first thing you do, is you figure out where 2 is. Is it in this domain, or this domain? If it's in the middle one, then f of x is equal to 3 no matter what x is, as long as x is between 0 and 5. So b is 3 also. Now, on c, what's in the parentheses is minus 0.5. Which function is that?
It's -2, since...
The top one.
Yeah.
In other words, there's 3 different piecewise functions here. This whole thing is called a piecewise function. But there's 3 different functions depending on what x is. And you're correct. In this case, since x is negative, it's less than 0, then f of x is minus 2. What's the value of f of 0? Well, because this top function says x is less than or equal to 0, then when x is equal to 0, the function is minus 2 again. Is the graph continuous? Well, it looks like you've graphed it pretty good. It's minus 2 whenever x is less than 0. It is 3 whenever x is between 0 and 5. And it's 10 whenever, there's a typo there. I don't know if you noticed it or not.
Which one?
Bottom one. It's not a typo. It's just written very funny. It's not a typo. Whenever x is greater than 5, then y is 10. And that's what your graph shows.
Okay.
Everything's copacetic. Now, let's talk about the difference between open circles and closed circles.
Yeah.
Open circle means can't be equal to that. Closed circle means it can be equal to that. So on the top piecewise function, since that says less than or equal to 0, I need a closed circle right there. Not sure what that dot is next to it. You don't really need that dot.
Yeah, it was just...
Doesn't hurt, but just confuses a little bit. But I definitely have a closed dot there because it says x is less than or equal to 0. And then in the middle piecewise function, I don't really go from 0 to 5. I go from 0, but it's greater than 0. Not greater than or equal to 0. So that's going to be an open circle, not a closed one.
Yeah.
But it is x is less than or equal to 5, so that's definitely a closed dot. And then the bottom one is only when x is greater than 5, not greater than or equal. So it's an open dot at 5. And then this dot really shouldn't be there.
Yeah, okay.
You would want to erase that. Only because it's a little confusing, especially if you have an open dot next to a closed dot so closely. It
yeah, it was just
confuses things a little bit.
Mm-hmm.
Okay. Answer E. Is the graph continuous? Well, the definition of continuity is if you have to pick up your pencil to draw it, then it's not continuous.
Mm-hmm.
That's pretty much the layman's definition of continuity. And that's all you're getting at this point. There's a more sophisticated calculus definition of continuity, but not that valuable for you to know. The only thing you need to know at the moment is, do I have to pick up my pencil? In other words, is that continuous?
Yes.
Because I didn't have to pick up my pencil.
Mm-hmm.
That continuous?
That whole thing? No.
No, because I had to pick up my pencil to draw it. And that's pretty much all you need. Now, there's one particular function that you're probably familiar with, y equals 1 over x. Looks like this. It's a hyperbola. Is that continuous?
No. Wait, yes. Wait.
Oh, it looks kind of continuous, but I had to pick up my pencil to draw it. So it cannot be continuous. In other words, there's actually a vertical asymptote going through that and a horizontal asymptote going through there.
Mm-hmm.
And the graph never crosses either of those asymptotes. So there's no way to draw it without picking up my pencil right here and going to there. That layman's definition of continuity is an excellent one, because everybody knows whether or not you have to pick up your pencil to draw it.
Mm-hmm. I can send you another thing that's a little bit more recent.
Well, whatever you want.
If you want to keep going through that, there's probably some more stuff you can show.
The best way to do this, Dominic, is for you to direct.
Okay.
Only because I have not sat through your class.
That's true.
And with math, there are all kinds of degrees of difficulty. And not only that, but you're in Florida, I'm in Colorado, and so there could definitely be differences in the way the different school systems here work than Florida, even though everybody is under Common Core at the moment, till Donald Trump has his way. But I still never know the degree of difficulty.
Okay.
What I've found out with your buddy Taylor is that, gosh, sometimes his degree of difficulty is all over the board. It's much greater than what I get here in Colorado. Sometimes it's regular and normal, but unless he brings me the problems, I'm doing the wrong degree of difficulty. If I'm doing Colorado degree of difficulty, it's not. Do you go to the same school as him?
Yeah, but he usually takes honors.
Okay. Even still, it's a private school, right? And private schools always are different than standard public schools in terms of their curriculum.
Okay. Well, I sent you another document.
Okay. Let me open it up. Might be. If it's more recent, then might be better.
It's basically what he gave us to practice for the test. Exactly.
That's what we want.
So it might be a little bit more, it might be a little bit better.
No, that's definitely what we want, is stuff that he's giving you for practice. I have neither given nor received unauthorized help on this work. Are you kidding me?
That's just, it's kind of a formality. Just, this wasn't, like, okay, it's not anything.
technically, aren't we violating that? But, I mean, I'm sure that he does not intend for that to be the case. I'm sure he's not saying you can't use a tutor.
No, it's just because that's what he has on the front test pages, and he tries to make this kind of like similar to the test, and it even has the same front page with like the name and the...
Basically saying somebody else hasn't taken this test for you.
Yeah.
Which is fine.
And this isn't the test.
No,
exactly. Like,
I have no problem with that anyway. All right, okay. Let's look at this. I do have a problem if other people are taking the test for you. I don't think that's...
No.
I don't have a problem with his statement there trying to exclude other people from taking the test from you, but it also makes it look like it doesn't allow tutoring, which is a little silly. I don't think any teacher would ever say that I don't want you to do tutoring.
It's authorized.
Yeah. So when it says what's the value of f of 2, which function are we using? The top, middle, or bottom?
The middle.
So what's f of 2?
12.
B. What's f of 5? Which function are we using?
Also 12, since it's greater than or equal, or less than or equal to 5.
What's f of minus 2? Which function are we using?
4, or the top one.
Okay. What's f of 0?
Also 4.
It's the top one because it says x less than or equal to 0, whereas the middle one says x greater than 0.
Yeah.
So 0 definitely falls in that domain right there. Can you see what I just did?
Mm-hmm.
Okay. Now, what's f of minus 2?
It's 4.
Also,
or the top one.
Also the top one. What's f of 0?
4.
Okay. What have I said? What is f of minus 3?
Minus 3.
Undefined.
Yeah, I guess nothing.
Right, because that's not in our domain. In other words, our domain covers from minus 2 to greater than 5. That's it.
Mm-hmm.
That's the only domains we're allowed to come up with an answer. If I have a number, if I have an x value that's not in this domain, then there is no answer for f of x.
Mm-hmm.
All 4 of what they asked were in our domain, so let's go to number 2. All right, composite functions.
Yeah, that's also one of the things we're going over.
Yeah, let's talk about composite functions. Let me write both of these. If I said to you, what is f of 3? What would it be?
F of 3?
Uh-huh.
It would be 3 times 3 times 21.
Okay. If I said to you, what is f of x plus 1? What would it be?
F of x plus 1.
Yeah, in other words, I would plug in x plus 1 wherever I saw x.
And then, and that's it, right?
That's the rule, is whatever's in the parentheses, you're going to plug in for x.
Mm-hmm.
Okay? So, what have I said? What is f of g of x? Which is what you're asking. Well, that means the same as f of x minus 4, right?
Okay. Yeah.
That's all you do. So, what is f of x minus 4? and give it in the unsimplified fashion first. In other words, the very first step is just to plug in whatever's in the parentheses wherever you see x in the f function.
Okay, so it'd be 2x minus 4 squared plus 3?
You got it. Now, they probably want that simplified. So I'm going to expand that. That becomes x squared minus 8x plus 16. Now I'm going to multiply the 2. So I get 2x squared minus 16x plus 32 plus 3. I'm going to keep simplifying until I have it down to a nice quadratic. There's my answer.
Okay.
Question?
But I haven't had to do that yet.
Well, that's what they're asking us to do. Where did I see that?
I don't know.
Oh.
I think you just saw the
I saw f of g. I was thinking f of g of x. It's f of g of 2. Well, that's okay. I actually did a harder problem. F of g of x is a little harder.
Yeah, I noticed.
But not that much. The principle is exactly the same.
Yeah.
However, I misread the problem. So let's figure out what g of 2 is.
It's, you plug in 2 for the x in the g problem, and it's just negative 2.
Okay. And now what they're really saying then is what is f, if they say f of g of 2,
And
then it's really saying f of minus 2, right?
yeah.
In other words, what I'm really doing is f of minus 2. Once I figure out what g of 2 is,
Yeah.
and it's f of minus 2, and let me go back here. So what's f of minus 2?
F of minus 2 is 11.
Yeah, I almost prefer it if you would give me that as
the whole thing? Okay.
Well, just because this is always the way you do it. Okay? If you're jumping straight to 11, you're either a genius at math or you're introducing the possibility of making mistakes. Okay?
Well, I just do it I do a lot of math in my head.
Well,
that's
that's great.
I've always done it.
I like that. I mean, I do too. I always have. But I always realize that I am potentially making mistakes by doing math in my head.
Mm-hmm.
And that the better way to do problems like this is to do it one step at a time, that being a very critical step. In other words, plugging it in for x is all I've done. Now it's very difficult to make a mistake. In other words, now when I simplify it, well, minus 2 squared is 4, so it's 2 times 4 plus 3, that's equal to 11. So you were perfectly right, and I'm not going to try to interfere with people that do math in their head, because that's the way I've always done it in my life. But just to let you know that it could
it could. It's probably like the only chance of you messing up something.
Right. If you want a chance to mess up, then try doing the whole thing all at once in your head. That's the best way to make a mistake. Now, the second part says, what is g of f of 2? Well, you always work from the inside out. So let's figure out what f of 2 is.
Mm-hmm.
What's f of 2?
F of 2 would be 2 times 2 squared plus 3.
Same 11.
Yeah, 11.
Coincidentally, not the same
Perfect.
exact. because the other one was f of
negative
minus 2.
Yeah.
Well, f of 2 happens to be the same number because you're squaring that. Whether it was minus or plus didn't really matter.
Mm-hmm.
So the problem now becomes, what is g of 11?
And it's just 11 minus 4. Yeah.
7, yeah. Composite functions are actually a piece of cake because as long as you do them one step at a time, you really can't mess up. I mean, you can't get in trouble. In other words, C is, what is g of f of minus 1? Well, the only thing you have to remember is work from the inside out. What's f of minus 1?
It's 5.
What's g of 5?
1.
That easy.
Yep.
What's g of 0?
It's just 0 minus 4.
Yeah. What's that doing is question D. That's the easy.
I don't know. Yeah, that's like just kind of like.
That should have been A.
Might have just been a gimme, like a throw you off kind of thing. I don't know.
No. Let's see. We just did 2, right? Yeah. We did 1 and 2. Okay. Let's look at 3. So they're basically giving you a word problem.
Yeah.
They're saying which piecewise function fits our word problem. Well, the only way I know to do these is to go through them one at a time. Well, A works for as long as you're between 0 and 2 hours, right? It's $10.
Yeah.
But if x is greater than 2, it's $3 for each subsequent hour. That's
not every hour.
That says. In other words, if you had 2 extra hours, this is going to charge you $16. Who circled this? You did or your teacher?
I did. Because I thought it was the right answer, is it?
No, I think it's A.
Really?
Yeah. Let's try some numbers. If you were here exactly 2 hours, what would you pay?
You'd pay $10.
If you were there exactly 4 hours, what would you pay?
$16.
Well, so far that's A. Not B. In other words, if I plug in, oh, excuse me, what did I say, 4 hours? No, my mistake. My apologies. B is correct. Sorry.
No problem.
My method was fine, which is to figure out what different times cost you, and then figure out which piecewise function goes with that. Well, you were right. If you're there 4 hours, you're going to pay 2 times 3 plus 10, so you're going to pay 16, and that is B. And only B. Only B gives you $16 as a cost if you're there for 4 hours. And that's really the way to do this problem, is to figure out some x that's greater than 2.
And see if it works?
Well, yeah, pretty much. In other words, that's always the proof of the pudding, is to make sure that it works. And in fact, this is a perfect example, because I thought A was correct, but when I plugged it in 4 hours, I didn't get 16. I got 22. So that tells me A is wrong.
Yeah, because it charges the first 2 hours. It charges $3 for the first 2 hours as well.
Exactly. Yeah.
I think I got A the first time too, so you don't have to be embarrassed.
Well, that shows you that the way to do these is to make sure that You pick a number and it verifies.
Mm-hmm.
And occasionally you could pick a number where you would have two different answers that would both be true. If that happens, pick a different number. And that will narrow it down. In other words, I picked x of 4, right? Well, what if x of 4, we actually ended up with a couple of answers that both gave us $16?
Then
we don't, but that would tell us that we don't know which one is correct. Well, go back and pick an x of 5.
Mm-hmm.
That will narrow it down. Always. In other words, if your first number gives you two answers that are correct, go back, change your first number, and you'll only have one answer left.
This next one kind of threw me for a loop.
Number 4? Okay.
Yeah.
Let me look at it for a second.
Okay.
So consider the function this. That tells you how much money you make over 3,500, right? Okay. And g of x tells you that whatever you're making, you're going to multiply by 3%, and that's the tax you're going to owe. If we want to use two functions to come up with a function to determine the amount of taxes paid given an income between 3,500 and 10,000 yen, what function would we come up with? Give both the composite notation and the final function. All right. We'll call it h of x. This is the amount of tax you're going to pay.
Okay.
Well, what if x is less than 3,500? How much tax do you pay?
Nothing.
Okay. So that's what h of x is if the domain is less than 3,500. If the domain is between 3,500 and 10,000, how much tax do you pay?
0.03%. Or 0.3%.
0.03x, right?
Yeah.
In other words, if you made 5,000, you would pay 3% of 5,000. As long as the amount you make is between 3,500 and 10,000, then you're going to pay exactly 3% on it.
Yep.
That's actually the answer. That's all they wanted.
Oh,
they said,
that's it?
Yeah, if we wanted to use these two functions to come up with a function to determine the amount of taxes paid given an income value between 3,500 and 10,000, what would it be? Well, in reality, it wouldn't be that one. It would just be this one. In other words, I don't need a piecewise function for that.
And that's why it's composite notation?
No, I don't.
What's composite notation mean?
Well, that means f of g of x, or g of f of x. That's what composite notation means. Now, why they ask give both the composite notation and the final function, I don't understand that. I don't know why they want you to give composite. Unless I'm misunderstanding this, there is only one answer, and that's g of x, or h of x. In other words, 0.03x. Unless I've misread the problem, it looks to me like if you make less than 3,500, you don't owe anything in tax. And if you make between 3,500 and 10,000, you owe 3% on everything you made. It says everything you made above 3,500. Okay, I didn't quite do that correctly. In other words, we don't, if we make 5,000, we don't pay 3% on 5,000. We pay 3% on the amount greater
than the difference. The difference.
Yeah, so here's the amount that we're going to pay 3% on. Everything greater than 3,500. So that really is our function. In other words, if you make 3,500 exactly, you don't pay anything in tax, right?
Mm-hmm.
If you make 3,600, then you
pay
3% of $100.
Mm-hmm.
And that's what this sentence says. 3% on everything above 3,500. And then they go on to tell you that this represents what is above 3,500. So it's pretty easy to put together the 0.03 times the x minus 3,500.
So that would be the final answer?
Yeah. Now, in terms of a composite function, I think I can do this. That is g of f of x. F of x was x minus 3,500. So it would be g of x minus 3,500, and g of x was 0.03x, right? In other words, they've given us that. That's what g of x is.
Okay.
Composite function means either g of f of x or f of g of x. And in this case, it's g of f of x. Well, this is f of x right there. F of x, as they've defined, is x minus 3,500. That's the amount over...
That's the amount you're getting taxed on, okay.
Yes. So the composite representation would be g of f of x, with f of x being x minus 3,500, which makes g of this be 0.03 times x minus 3,500, which is what we know is the answer. So in terms of their question, this is the composite notation, or even perhaps that. This is the final function.
Just 0.3 times the whatever you're getting taxed on, I guess.
0.03 times x minus 3,500.
Yeah, that's what I meant.
Okay.
Okay.
Let's go down. We doing a half hour or an hour today, Dominic?
I don't know. I didn't set up the appointment.
Okay.
I guess an hour,
okay.
unless okay.
We can do whatever you want.
I'm pretty sure Taylor is set up right after me. That's what he said.
Yeah, he is. In fact, this is really weird. This is spring break in Colorado, so I have very little appointments this week, and I have 4 in a row today. Even though I only had 7 the whole week, I ended up with 4 in a row today. So
yeah, we don't have spring break for like another month.
You're kidding.
Or not another month. That was like 2 weeks ago when I was a month. Now it's like another 2 weeks.
Yeah. No, I know they, what's the word I'm trying to think? They stagger them.
Yeah.
All right. So let's graph this function. Hold on. Let me. Now this might be the one scenario where in-person tutoring would be better than online. But I think we can do this online. The way to always look at these piecewise functions is to look at the domain first. The top domain is x less than or equal to 0. That means this entire area is where I want to draw that first function, 2 plus x.
Okay.
Okay? how do I draw that function, 2 plus x?
You plug in any number and then...
No, there's an easier way to do it. If I told you y equals x plus 2, how would you graph that? What's the y-intercept?
2.
What's the slope? Slope is the coefficient of x. In other words, I've got this thing in y equals mx plus b format. So
it's any. You just plug it in, right?
Well, it's 1. It's the coefficient of x. You don't plug it in. It's whatever the coefficient of x is. It's just not written here. In other words, it's assumed 1. Okay, but I can draw that function. That's about a 45-degree straight line. Now the reason I drew it dotted to the right and solid to the left is because this line is only the function to the left of 0.
Yeah.
So I'm going to go back and erase that. That's one way to do these. Not necessarily the way I would recommend. The way I would recommend is plug in x equals 0, and you know this point right there, 2. Now you know the slope is 1, so I can figure out that the slope is 1 from that line. That's my function. Now, is that a solid dot or an open dot?
It's a closed one or a solid one because it's greater than or equal to.
Exactly.
Or less than or equal to, I mean.
Correct. Okay, now let's find the rest of the domain. In other words, the next part of the domain is between 0 and 3. So we're looking at this area here.
It is 3.
Okay.
So it'd be
just 3. Yeah.
So
the straight line, horizontal line.
Yep.
At 3. Open, closed dots, which way? On the left?
There's an open dot at 0, x, and then a shaded dot at 3.
Okay. And then finally, the last domain is everything to the right of that, all the way up to infinity. So
yeah, because it's
in this red area that we want to plot the last function, what's a good starting spot?
4. I guess.
Normally, I would say 8.
Oh.
Because that's the y-intercept.
Okay.
The problem is this line doesn't go to the y-intercept.
Okay.
So if I plotted 8 and graphed the line, I would have to erase the part that was between 0 and 3. Well, you don't want to do that. So the best thing to do is plug in x equal 3. And I know that sounds a little counterintuitive because it says x greater than 3 right there.
Oh, I remember, yeah, my teacher said this once. I kind of forgot it, though.
Yeah, but if you plug in 3, then the function is 5. So I know the function starts with an open dot at 5. So I don't need to go all the way over to the y-axis. I can start at that dotted line.
Yeah.
Now what's the slope?
It's 0, right?
The coefficient of x.
Oh, it's -1?
Negative 1.
Oh, okay. -1, so it goes down.
Is a negative slope, 45-degree line. And that goes on forever. In other words, that goes to infinity on the x-axis.
Doesn't it also go to infinity on the other side?
No, it stops right here. Oh, yes, down here. Sorry, it does, yes.
Okay.
Yeah.
Okay.
But notice that I did not graph this line using y equal mx plus b. In other words, I could have, but I would have had to go back to 8 and draw that all the way back to the y-axis, and then erase it. Erase the part that's not in our domain. So I could have done it that way. But that's not the best way to do it. The best way to do it is to take the restrictions of your domain, which is the line 3, and plug it in and see where that thing starts. Now it starts with an open circle, but it still starts at 5. So I don't have to go to 8 to figure out where that line is. In fact, each of these things, I can go to 0, I can go to 3, and figure out where they all start. And I don't have to use y equals mx plus b format to do this. So this is my final graph.
Okay.
Okay.
Yep. What's the next one?
All right.
If we have time.
Yeah, we do. Oh, we started at 4, didn't we? Oh, yeah.
Yeah, time flies.
Well on our way to an hour. For some reason, I was mistiming it when I asked you that question before.
Yeah, it was already about 4:30 when you asked.
Yeah. Okay.
Time flies when you're having fun.
G of f of x. Start from the inside. So what are they really saying? G of what?
G of 5.
No? What? Well, let's first of all...
oh, wait, no. Oh, no.
Go ahead.
When f of x equals 5, I'm guessing.
Well, in other words, they're saying g of f of x. Well, what is g of f of x? G of f of x is g of 3x minus 5, right?
Yeah.
Okay.
So let's see.
So let's figure out what that is. Then we'll set it equal to 5 and solve it. Because they're telling us that that's equal to 5. But what is it in function notation?
It's equal to the square root of x plus 3.
Well, what's x?
Or the square root of x, or 3x minus 5 plus 3.
There you go, minus 3.
Why minus 3?
Ah.
Oh, it is plus 3?
No, it's minus 3, is it not? Oh, it's plus 3. I wrote it down wrong. Sorry.
Oh, okay. Yeah, I was looking at the paper.
Yeah, no, I was looking at my notes. Okay. So that's what g of 3x minus 5 is equal to. And they tell us that that's equal to 5. So I'm going to set that equal to 5 and solve for what x is. What's the first step of that solution?
Minus 3.
No, that 3 is inside the radical.
Oh. Okay.
Get rid of the radical.
Oh, yeah. You multiply it.
Square both sides.
Okay, yeah, square both sides.
If I square both sides, I lose the radical, and I end up with what's exactly under the radical. If I square the right side, I get 25. Now I got a simple equation to solve. In other words, I get 3x equals 27, x equals 9.
Okay.
Okay?
So then...
That's all they want.
That's the answer. Okay.
What are the possible values of x? Well, I only got one.
Could there be more?
Don't think so.
I don't think so either.
The way this is set up, this has got to be 25. That's the only thing it can be. And x equal 9 is the only thing that produces 25 inside the radical.
Yeah, there's only like really one way you can do it, so I guess that's it.
Yeah, sometimes there could be two answers, but not in this case.
Yeah. Okay. Is that it for the thing, or is there more?
Well, for that question, number 6 is all they want, or what are the possible values of x?
Uh-huh. I meant, is there more questions? Because I'm not even sure. I didn't even get this far.
Yeah, there are.
Oh, okay.
7. We probably got time to do number 7.
Okay. Let's do it. And then we can finish, I guess.
Now, we're looking at a piecewise function, correct?
Yeah.
Okay. So the one thing we want for sure is minus 5 in the middle function.
Yeah.
Well, that's A or B, not C, or D or E. So anything but C. Okay? Now, let's look to the left. When x is less than 0, what does this function look like? What's the slope on? Well, first of all, what would the y-intercept be?
It would be 2.
What's the slope?
1 plus 1?
Minus 1. That is a negative slope.
Oh, it is?
Yeah. The one thing you want to definitely know is whether you're looking at positive or negative slopes. Okay? Let's talk about that in a few minutes. This is so important. I'm going to draw a slope. You tell me if it's positive or negative. That one right there.
That's positive. Positive. Negative.
Okay.
Negative.
Okay. So this slope is clearly negative, right?
Yeah. Yeah.
Okay.
So I was just looking at the arrow pointing upwards, kind of like, yeah.
That's all right. That's all right. No. So what's the equation of that line? If that slope is minus 1, in other words, if the slope is minus 1 and the y-intercept is at 2, what's the equation of the line?
Y equals minus 1 plus 2? Or minus 1x, or minus x, yeah.
That's the equation of that line. And that's A. And the second part is minus 5. That's correct.
And then
let's look at the third part. When x is greater than 5, is that our equation? Well, that looks like a positive slope that easily could be 2. In fact, it does go up 4 to the right 2, so that has a slope of 2. Now the question is it minus 10? Well,
we gotta look closer, right?
Actually not. Just plug in 5 for x. Does it equal 0?
Yeah.
Which is that point right there. So A appears to define this thing perfectly.
Geez, that's the second. No, it's not. The last one was B. So I guess it is A?
Yeah, I think it is. Let me just see if there's any differences. It's definitely minus x plus 2 on the top. So that eliminates B. It could be C, but C was eliminated because the middle was wrong. So D has the first one correct, the middle one correct. Notice the only difference between D and A. D is exactly the same as A, except here x is greater than or equal to 5, and in A, x had to be greater than 5. Well, picture tells the story. Which one is it?
It's A.
Yeah. X is greater than 5. It's not greater than or equal to. Otherwise, that would be a solid dot.
Uh-huh.
All right. That's a good stopping spot.
Yeah. Yep.
Dominic, I talked to your mom a little bit today. Wendy is your mom, is that right?
She's my aunt.
She's your aunt? Okay.
Yeah.
I honestly think that your best way forward is to schedule regular sessions, half-hour long, twice a week.
Okay.
That'll give you an hour of tutoring a week, and it won't end up being the way that it has kind of worked, which is you schedule a half hour or an hour session right before a test and it's all crammed. That's a terrible way to learn math. It really is. The way to learn math is slow and steady. In other words, even if you don't have a test Friday, it's worth you putting in a half hour on Monday and Wednesday to learn the math. And then come test time, you'll do fine. You don't have to have an hour session the night before the test. And that's kind of what all my students believe. And that's why when finals come around, man, I am jam-packed for 2 weeks before finals. I hate to see that. Even though I can't keep students from doing it, they all do it. But it's honestly, I do not believe it's the best way to learn math. I think the best way is slow and steady. So if I were you and I really wanted to get a decent score in math, and you should, even if you do not have any intention of ever doing anything in your life that requires algebra, that's not the reason you take algebra. The reason you take algebra is because it improves your critical thinking skills.
That's actually what my teacher just told me today. He actually said that.
I promised I did not talk to him.
I know.
It's what I believe, because a lot of students think that, gosh, they're going to be an English major or a musician or something. They're never going to need algebra in their life. And that might be true. But learning this improves your ability to analyze the world in a quantitative manner, which is improving your critical thinking skills. That's why we learn math. It really is. I mean, a small percentage of us that learn math go on and become engineers. But that's not why everybody takes math. Everybody takes math because the world deems that they want everybody to have good critical thinking skills. That's why you want to take math. And it doesn't stop. You could go all the way to calculus if you had the ability. Even though you might never need calculus, mere fact that you're taking it and could master it says a lot to everybody, the world.
Yeah.
Doesn't matter if you're going to be an engineer. If you get an A on calculus in high school, you're going to make college administrators stand up and take notice. No matter what you're going to major in. So just keep that in mind. I know your aunt mentioned there were some motivation problems with you, that you just weren't that motivated to learn math, but
yeah, I wasn't against math in particular, to be honest.
Oh, was it all subjects?
Pretty much, except for the ones that just kind of come naturally.
Well, that's a phase that every teenager goes through. I don't know what to tell you about that.
Oh yeah, I don't know. It's just...
It's hard to convince teenagers that an education is really, really valuable. And I mean really, really valuable. And the problem is if you get... I've got a son that's 26 years old, and he never really learned that an education was really valuable, so he stopped after high school. And now he realizes how valuable it was, but it's almost too late. I mean, it's never really too late to go back to college, but in some ways it is. And he would have been so much better off going to college immediately, merely because accepting that an education is required in our society. Unless you're a fantastic football player or basketball player or something, and you're just absolutely certain you're going to make your living doing that, then in all likelihood you're going to need an education. I will stop talking and I will let you go, and I'll get together with Taylor here.
Okay.
5 minutes late for Taylor. So it's good talking to you again, Dominic, and think about what I said, and if I were you, I would try to set up something regular with me.
Okay.
Okay?
Yep.
All right.
Okay. Well,
Bye-bye.
see you next time.
You too.
Goodbye.